You're listening to Data Center Therapy. Please take a number, and an engineer will be right with you.
That worked out okay. Hello, everyone, and welcome to a very special recording. Everyone's laughing. It's good. This is going to be great. A very special episode of Data Center Therapy. Data Center Therapy Live. We are absolutely live right now, broadcasting on Zoom. We have some attendees. Hello, everyone. Welcome. Thank you for joining us. We will have Q&A throughout the episode. We have the panel, I believe, open, so feel free to submit questions, and we'll try to work them in as we go. So, I am Matt Yeti. I am joined by my co-host, Matt Cozzolino. Matt, how are you?
I'm great. How are you guys doing?
Good. We have a special guest to go along with this special episode, and who better than one of our original hosts, Mr. Chris Crow. Chris, hello.
Hey, how's everyone doing?
It is so good to have you back, and that little funky intro that you all just heard, that is a product of Chris Crow, by the way. He spit us out the intro, the outro, and then left Ivoxy.
One of those bases hanging on the wall behind you, right?
Yeah, well, it's actually over to my right, but yeah, I'm a little bit of a collector.
Well, I mean, we appreciate you granting us the license to use those tracks, and they've come in handy. But you are obviously no longer with Ivoxy. But what are you up to right now?
Well, I actually moved over to Pure Storage fairly recently, so yeah, nice position opened up, and and I'm sure you guys have been working with Pure Storage quite a bit. It's a fantastic place to work on the other end as well, and I've really appreciated their products over the years, because obviously worked with them quite a bit when I was at Ivoxy.
Here's an interesting question, and we're obviously large fans of Pure here too. Is it challenging? It's got to be different. And take me seriously here, because I'm not being sarcastic. What is the extra value somebody smart like Chris Crow brings when the product already is so strong, right? And really, leans heavy into simplicity, leans into performance. But I mean, when you walk in and say, "We make one of the best products out there," buy it, right? When you're representing a strong product, does that make things tougher for you, or easier?
Oh,
isn't that weird? Do you
that
know
is
what I'm trying to say?
No, I do, because it's but the thing about SEs is the amount of specialization that we really carry can only go so far anyway, because and you kind of realize this at a particular point. You say, well, now I just have to worry about Pure. But I'm not a product engineer, so I don't have that level of a particular system. But then you talk to a product engineer, and they only know a particular part of Pure. So it's tough, but where I find most of the value is really around the ecosystem. It's one thing to say, well, I can hook Pure up. Well, okay. It's another, and current specializations for me are look like they're moving towards like Kubernetes. So how do you load a sidecar container with PSO in it? Yeah, Matt was actually an early proponent of that, so it's come full circle. We should get a beer sometime, Matt, so I can pick your brain about some of this. But and so that's where I find a lot of it. And it was true at previous places as well, right? The value is not necessarily knowing, memorizing how many, IOPS a system can do, or, otherwise why do you even need an engineer? It's the ecosystem.
Mm-hmm.
Yeah. What strategies do you have to get this to play with cloud storage, or containerization, or OpenStack, or vVols, or things like that? But it is kind of fun being able to get a little more into the weeds with new media types that come out. You get to see stuff. It's nice. So hopefully that kind of answers it. I don't know.
No, and
otherwise
what kind of
it's really
Trebek would I be if I didn't already know the answer to the question, right? Or the question. To the
well,
answer.
I was just going to say I'm bringing a winning personality.
And the smiling face and the
right,
shiny...
a bit of a low voice, try to hypnotize a few people. It's really all I have going for me.
I don't know. I've run into that ever since I did my Cisco classes. It's like there's this definite demarc between what you have to know and what is something else's problem. Like you're a storage admin, right? You don't really have to care that much about what the thing's doing, what VMware's doing, or what iSCSI connections are doing, because it's just that next bit.
But as soon as you get into an integration point, vVols being a good example.
Yeah, you gotta understand the broader side. I think that's what Ivoxy brings, is we can do that integration. We see that, so it's cool to see you there. And I know that when you get out there and you can talk about it, it's got back when I was installing these things, here's all the VMware stuff I had to care about, and so worry about some of this stuff also. Yeah.
Well, it's funny. I installed more Pure
arrays. That's one
of
the things I think that's to your point too, Mr. Coslino, that when you can come at it from all angles, I believe, regardless, I mean, not to say that we know all or anybody knows all, but it does carry more credibility because you can say, look, I empathize with you. I've lived that. We are all, at one point, we're all ops guys, right? So that we know what it's like to operate in an environment and what the challenges are. So we hope that we're coming not from this ivory tower of, oh, you should do this, but no. We know your pain, and we want to feed you that aspirin.
Because you'll get a whole different set of questions depending on who's in the room, right? You get a bunch of VMware guys in the room. It's all vVols and how should I mount this data store, and then you get a couple of network guys that have to be part of the implementation, and it's a whole different set of questions, right?
Oh yeah.
So you mentioned vVols. And this is one of those topics that I've had a lot of customers say, hey, should I do vVols? And what I like to do is I like to put it back, okay, you're bringing this up for a reason. Why do you want vVols? What have you heard? Well, I just heard it's the thing.
It's
and
shiny.
For me, that's not it's not something. That doesn't necessarily mean a thing is just a thing. Is it interesting? Is it useful? Is it helpful? Is it efficient? So I'm going to put you on the spot then, Chris. So what am I gaining? Where did they come from? What is it? How is it different from VMFS? What do I care? And if you just say it's different, I'm throwing you off the pot.
Well, I'm going to start by saying it's different. No, I'm kidding. It's vVols are kind of an interesting, really an interesting topic. And I used to, I'm sure a few people have probably taken VMware classes from me before, and so I've kind of expanded this talk track a little bit, moving on. But I think the basic way of thinking of it, because it has to solve a particular problem for you, right? And the first kind of stab at that, I always used to do this within the class. My best movie guy voice of imagine a world where all of your VMs, each VM had its own LUN. Now, why would that potentially be advantageous? We can think of a lot of reasons it's a terrible idea, right? Who wants to manage that many LUNs? Can we do trivia with the audience? Like, what's the maximum amount of LUNs an ESX host can handle? 256. So you run into a limit really, really quickly. Plus, but what would be some of the advantages? You could have different snapshot policies for each system. You could or each virtual machine. You could have different replication policies. All of those sorts of things. I think that misses what vVols, another advantage that vVols have, which is also they're somewhat similar to, and I know you might throw me off for this statement, to raw device maps. And so hear me out on this whole thing.
Okay.
What vVols are trying to solve is closer array integrations through APIs. Because if we think about how VMFS works, it's just one way. The ESX host is talking through SCSI 3 down to the storage, and that's the channel it has. Also some VAI. VASA, which is really the APIs that are powering vVols, provides a two-way communication channel, both from the vSphere environment to the array, and also from the array back to the vSphere environment. So, how does it work? You start with something called a protocol endpoint. And a protocol endpoint is the termination that allows us to get around this huge LUN amount. Think of it like a proxy LUN. The ESX server mounts a single LUN, and all I/O is proxied to the actual storage object that the virtual machines have. So if we kind of walk through the life cycle of a virtual machine with this, and I wish I had my whiteboard or some visual aids here, but we'll try. After it's set up, when you provision a new virtual machine and select vVols, through VASA, the system says, okay, this SQL server has 5 disks. So I'm going to create one storage object, we call them volumes, for each disk. And then I'm going to create one for configurations, and then I'm going to create one for swap when the system powers on. It does all of that automatically. Once the machine powers on, and here's another kind of fun little question.
If I can pause you then, Chris,
yeah.
I just say that's what you're describing makes complete sense. I don't even think it's I'm not saying good or bad. That's where my apprehension has always come in terms of the automating of it all. Because at a certain point you have to say, I trust you. Take care of it. I don't necessarily need to know the details because it's there. And the quality of software nowadays, I feel like, and this is not specific to Pure or anything, it's just overall general statement, I'm going to want to get my hands in from time to time, I think, at least. And that might be a misguided point of view. But I'm going to want to get my hands in there, and I feel like if I've given this part up to this automated process that goes ahead and provisions with non-identifiable GUIDs and et cetera, I'm now I've got that much taller of a stair to climb to troubleshoot should I need to get to the top of that hill.
And that's absolutely true. And so I think talking about a couple failure scenarios, but I'd also say that the technology tends to, there's a reason that we march forward with this stuff. There's a reason that we abandoned BSD's RC files in favor of System V and now, what's the new one from System D?
Are you really going
to
systems. RC versus System D debate? You didn't just
do
what?
That. I've spent enough time lately with well. Why are people? Why do people no longer use RC files?
Chris Crow from it.
Anyway,
sorry, I'm sorry. Go ahead, Chris. Sorry.
Because there's reasons and a lot of that is because we want scale, automation, and modularity inside of systems. Because systems are more or less having to be more and more distributed as time goes on. But anyway, so what are the actual benefits of this? When I boot that SQL server and start installing Windows, and I format my C drive with NTFS, what's actually happening under the covers? Well, I created a volume as part of VASA, and this is what's kind of interesting about you wanting to touch this, Matt, figuratively, this is a discrete volume. It's formatted with NTFS. So if I ask a couple of questions about that, these 5 volumes were created, could I take a snap on the array of that? Yeah. Could I take a clone of that on the array and mount it to a different system? Yeah. Could I take a clone of that volume and mount it to a Hyper-V server over iSCSI? Yeah. And here's where it gets particularly interesting to me. Can I take a replica of that I've shot up to AWS and hand it to an EC2 instance? Yeah. So all of these things tend to open up. So it tends to help with mobility. And that's the reason for my RDM thing. It's probably not the best of examples.
Would it be appropriate to say that we're removing VMFS from the container we're storing this, and we're writing the blocks straight to the storage array using the native NTFS, the native OS
absolutely.
file system? Okay.
And VMFS has nothing to do with this, so we have to rethink a couple of other things that we've learned about. What happens when you snap the system? VASA tells the Pure array to take a snapshot.
Okay.
What happens when you clone it? VASA tells the Pure array to clone the system. Right. These. So, in that way, it provides quite a bit of portability. I'm going to stop short of saying performance because VMFS is performant and set up right. We all know that unless we do something dumb like have just queuing issues or things like that, it works. Or if you're thin provisioning and just expanding a volume, there's always caveats places.
Is there an underlying storage protocol that it's leveraging? Like, is it still leveraging iSCSI to write those commands from?
Oh yeah. So remember back to the protocol endpoint, right? It's and here's the thing: a protocol endpoint is, because it's almost easier to describe vVols with what it isn't, because it's not a protocol, it's not a file system format. vVols are a combination of a protocol endpoint, which can be NFS, iSCSI, or Fiber Channel, and a VASA provider. And that's pretty much it. So a couple of things that if we start to logically think through this, okay, great. By the way, where is the VASA provider on a Pure array? It's sitting statelessly on the controller. What happens if I could somehow, I don't think this is actually possible, but if I terminated the VASA provider, what happens to the data pathways?
You think
And
that path would go down?
It does not,
okay.
right? Because remember, it's the protocol endpoint
that's separating
still
the control
connected
plane from the.
It's separating the control plane.
That's like rebooting your NSX managers.
Or rebooting vCenter.
Yeah.
Now, you can have disruptions under the wrong circumstances, right? If your VASA provider goes away, in fact, it's funny, I had a customer that just upgraded with vVols. They configured vVols like, I don't know, a year ago or something, forgot about it, had a few machines on it, upgraded the array, vVols gets, the VASA provider gets unconfigured, and everything keeps trucking along. He didn't realize it.
I would assume provisioning operations or things of that nature would fail you, which again is like a vCenter. I'm all right with it,
right?
Because as long as things operate and don't fail.
Is there a way to get the data off of there, like a storage vMotion-esque onto a traditional type of storage?
You're going to need,
or is that context like completely gone now because you don't have that context of a VMDK anymore, right?
You don't, and you need the VASA provider to be able to do that. So they need to be resilient, right? A design that would say the VASA provider has a single point of failure and is being deployed as something else, I think probably has some architectural challenges. I wouldn't do that. And neither, by the way, I think if I was running, going back to that ops statement, if I was running a virtual environment, I don't think I would have a management cluster using vVols for its storage provisioning. Kind of in the same way, like, think about vSAN, right? Back to imagine a world where every server has its own storage, right? But anyway, I don't think, and I'd be curious for people's thoughts on this. I wouldn't deploy a vSAN as a management cluster that is hosting the vCenter system.
I wouldn't deploy a VDS if you don't have to. Just like you say, if you want to manage these things, strip it down to with as few bells and whistles as possible. Matt, you might disagree, maybe.
I mean, I was gonna ask a different question. So more and more, I've been getting into design of larger environments, and there is that definitive need for a management cluster to run vCenter and this management VM.
It's more important too, with NSX being more and more ingrained.
Yeah. What I was going to ask is are we then reliant on the storage array to do replication and presentation of that volume to different host clusters? So I get the ability with NSX to have two clusters that are effectively the same. I can have the same subnet spanned across them. And I'd have to rely on something like vSAN to be able to have consistent storage across those two environments, right? Can we do something with a storage array underneath that to have that same functionality? Or
that's a whole different.
Is that a whole okay?
That's a whole different rabbit hole. So here's the thing. Because one way or the other, you need to talk about a metro configuration. If we're talking about taking storage, and you want a failure scenario that can
handle the other site, yeah.
But I mean, it's too late. The site went down. The localized black hole opened up. We need to be able to.
You've got your active synchronous.
And that depends. And that's really what it needs to be. Which, by the way, so Pure has a feature called Active Cluster. And by the way, Active Cluster does not work with vVols. So we're separate topics here. Yet. Active Cluster.
Asterisk.
That
I know of.
I've ever heard one.
So Active Cluster's job is doing exactly that.
Okay.
Is having two arrays, accepting writes on both arrays. In fact, the same LUN serial number will show up to both sites. And funny enough, this is actually a configuration that you see every once in a while. Imagine that you have ESX hosts on either side of this metro configuration, but the ESX hosts cannot talk to the other storage array in the other site. That's actually a supported topology with Active Cluster where, so what needs to happen in that scenario, if I walked over, and I had a customer do this 2 weeks ago, it's the most fun, I think, you can have. And I would encourage people to test this before it goes into production, right? So he walked up to the Pure array and he unplugged both power leads. So Pure Array goes down. The ESX hosts on that particular site, because they could not access, one was in Tukwila, one was in the Weston. The ESX host on the localized site that went down could not talk to their local storage any longer. So what does the ESX host do with that? And the answer, of course, is how have you configured VMware component protection, which I'm sure, I'll say it again, but make sure you review those settings, talk to the mats. I love being able to say that. They can help you with the right setting. But essentially, the ESX server needs to say, the storage is dead. I need to restart this somewhere else. At that point, because remember, the LUN, it just turned into an access problem. Half of your ESX hosts suddenly lost access to the LUN, but the LUN started working somewhere, still working, in the Weston data center. So the ESX hosts over there immediately start to try to power on these virtual machines because you have properly configured VMware component protection. So that's how at least my customers are dealing with trying to get more availability than what a single array can provide. Because no matter how bulletproof a thing is, if you walk and unplug both power leads, it's going down. Mm-hmm. And so if you have those sorts of failure scenarios, you have to think of something different to do this.
So if I could shift gears a little bit here, stay on the Pure path, but kind of go at you a little bit, if you don't mind. And basically what I'm dealing with a lot of times now, or from an engineering operations standpoint, is anybody who's a Pure customer, very happy customer. I think it's one of the very few products that I have where I don't have a customer really who says, I got rid of Pure, I didn't really like it, didn't work for me.
It was too slow.
That being said, all flash is now almost ubiquitous, right? And it's getting to the point with efficiencies, depending on your manufacturer or whatever, but it's getting to the point where, from a cost standpoint, for similar capacities, you're getting close on cost. And I think, going forward, Pure saw earlier than anyone that all flash was the foreseeable future. And they've continued to stay ahead with NVMe, being out now for a couple of years plus. But I am Joe Blow with an array, and it's all flash, and it's going to give me a certain amount of IOPS that may be more than I need. How does Pure differentiate when everybody else inevitably puts SSD or NVMe chips in their array? How does Pure differentiate themselves, right?
So if I'm right, the parameter you gave me around that is how do we differentiate ourselves from a capacity standpoint instead of performance? Because Joe does not,
I'm not
care about
my
performance.
handful of USB drives are all flash, right?
Oh, sure, yeah. My Synology array can do a definite number of IOs that's higher than 20.
Sure. Sure.
And lower than 22.
It doesn't necessarily need to be on any of those battle lines, right? Just overall, what makes one SSD drive different than another, or how is NVMe different? Why does it, you're hearing these buzzwords, right? And you're under this constant deluge of marketecture. Oh, yeah.
Well, so we'll call this a little bit of dispelling some things. So first I'd say flash arrays need efficiency, right? If you have a flash array that's not doing compression or deduplication, then, and by the way, this feature I'm tempted at times to tout this as a feature. Hey, our array does deduplication. My customers don't care about that. What they care about is how much they can stuff on the array at a particular price point. So really having a good dedupe and compression engine is for me, but just to be clear about that. But I think in the same way that we have historically run into a performance bottleneck with spinning disk, we are going to start seeing those performance bottlenecks hit flash media. Because if we think about this evolution of how storage media worked, we have NAND. My other Chris Crow's trivia, what does that stand for? It's not actually an initialism, not and, but anyway, it's a logic gate. This is where unfortunately it's live, so you can't cut these bits out yet. So I'm sorry to the audience.
No, there's no way.
Why would we?
Yeah, we're gonna go down the
video.
So, yeah. Have you thought about a video podcast? Yeah, I have a face for radio. So you have this really fast media that's on there, and let's ignore for a moment different media types and stuff like that. We then decided as an industry that we were going to put that on the other end of a SAS controller. Why? Well, because that's what a computer used, right? They went from SCSI to BSAS interfaces to. Fundamentally, though, flash is not a spinning disk. A spinning disk does not have issues with write leveling. It doesn't need trim support. All of these sorts of features, so you don't have to do over provisioning on a spinning disk.
Spinning disk
and so,
is like an empty warehouse versus what am I putting in that warehouse in a bunch of boxes,
right? Right, and let's face it. I mean, it's magnets and spinning platters, right? It's actually a little fun and analog.
Yeah.
Which I'm going to look forward to when I'm even older and can remind some of the young people of what a hard drive crash really meant. No, this was a physical event. That dreaded clicking sound. So it was really there for compatibility, but we opened up what is potentially a bottleneck. You have a single disk queue. So when you're sending commands down to a particular disk, and the entire system is built on this. I mean, think about the chain of I/O. You have a virtual machine that has a serial interface or a para-virtualized SCSI or something, but it's SCSI. That then connects to VMware, runs across the kernel, connects over iSCSI, which is fundamentally serial with a disk queue, to then go into the array that then starts talking to disks with single disk queues. What NVMe is doing, and by the way, NVMe is really it's a protocol. It's plugging NAND directly into a PCI interface. And so what NVMe is providing is opening up those channels. But the other thing, so you can have 64,000 queues instead of one. And if we play a little bit of a game of which is a higher number, one of those is a little more advantageous to us. But the other thing that it does is it removes some complication, and we can stop thinking of an array with drives. Like when you look at a pure array, and we call them flash modules. You can call them whatever, but when I pull that out, it has what looks a little like a PCI interface on it. But the pure array doesn't look at, well, I have 24 flash modules or 28 flash modules. It looks at, I have this much NAND on the other end of an interface. So as cells start to burn out, it can figure out how to move that stuff around. And what we're seeing is more and more, and especially
and it's not wholesale. I have to move everything off of this physical tray of SSD.
The cell burnt out.
Yeah. It's
so
just the one cell. Yeah.
Which is funny because if you have a SAS drive that's SSD in your computer, what is doing that work when a cell burns out? It's the firmware on the drive. Mm-hmm. Which is kind of interesting. I don't know how people have had with luck. Like I do run some SSDs in my Synology array, and their lifespan and the way that they're handled is interesting. I configured mine with RAID 5, doesn't have trim support. I'll have a treatise on why trim is important at a later time. But anyway, so an NVMe array is addressing is using NVMe as its protocol to talk to those flash modules. We're going to see this move. So right now, you talk iSCSI to an array. That's going to move to an NVMe over Fabric. Things like Rocky, right? That were, Linux had support for it early. vSphere 7 has support for it. That is taking a particular adapter card, a converged adapter, a switch that can support it, and an array that can support it. And now suddenly your ESX server can talk NVMe as a protocol.
I think this is going to provide.
So when you say all the way to, it's kind of
at some point I want to talk to a pure array and not a bunch of pure chips, right? Because I'm reliant on your fancy pure software to do all that stuff, right?
Exactly. Right. You're definitely talking to purity that's on the array. Right. You're not needing to do the logic of addressing NAND chips, right?
The new array, hey, you do it
That'd
yourself.
be something else. Yeah, right? it's pretty much,
but it's fast.
We ship you a box. It's like a Dell. They come in their own box. You just put it together. And
do you have a soldering iron?
That's right. You just have to write your own wear leveling software. It's no problem. Which I think is going. So first, that removes some complication from the entire stack. Second, it does actually decrease latency. There's less we have to worry about. So in testing, this is what's going to start. We're starting to measure things now in microseconds a lot. So this is getting us closer to the, below the traditional, 150 to 500 microseconds down to, flat 100. And we'll see where that it'll be interesting to see where that goes. But and you guys will find this funny. When I'm doing performance sizing these days, it used to be you put in a pure array, you wouldn't bother with performance sizing back when I was at iVoxy. That's not the case anymore. I have a couple of configs that are like, well, this one database server, it's pushing 100,000 IOs at a 77K average request size. That's a non-trivial number, and that's only going to get bigger. So so we need something that can scale, because at the end of all of this, and part of it is I'm tired of doing unnatural things. It'll be nicer to not have to worry about things like, well, I need to have 15 disks on my SQL server to get around disk queuing issues and things like that.
Yeah. As we all
it's interesting. Yeah.
Oh, there you go.
I appreciate the dive into that, Chris, because it's something that, like you say, you operate from what you've seen in your review mirror, right? It's very tough, I think, for us to really truly look forward and say this is how things are going to be, or this is where bottlenecks are going to show up. I mean, we all used to build PCs, and we would cram the fastest CPU in, and it would play the games for 6 months until it wouldn't. And now we're to the point where the CPUs have barely moved. The bottleneck has shifted to the GPU, and
So I see a question here from Scott, and I think
just a comment. No, I saw that. It's actually really good. Because and for those that can't see the chat, Scott's saying, hey, this is actually removing layers of potential troubleshooting between the ESX host between the,
because I don't have to go track down the data store, and I might have 5-6 data stores. I don't have to track that down anymore. I can just find that GUID for that one item on the array.
And it's important to keep in mind that we're still moving I/O over the ESX kernel. So it's something that's there, but and it's really your ratio of a particular storage object is 1-to-1 to the disk of the virtual machine, and that's what I think provides a lot of that flexibility, because like I mentioned in the beginning, you can just you can take our fictitious SQL server that has its 5 disks. You can take one of those data disks, or its database and log disk, and hook it up somewhere else. That's just fine. You could even hook it up, directly from iSCSI from a virtual machine. So I think, it's a really great comment.
Do you find if you're going to go with vVols, you should go all in, or is there any danger to keeping a little bit of legacy design data stores around?
Well, for your management cluster, for sure, right?
Yeah. I mean, okay, yeah.
And I do think that is the main consideration I have. And back when I was talking about this before, and I don't know if you guys shared this, but a couple of years ago, it was a struggle to find customers running vVols. I remember a guy that was on the vSAN team from VMware saying to one of my classes, it feels like vVols are really a solution in search of a problem.
For now. Now it's changed.
Changing. I'd say changing, but and a lot of it is, frankly, back then I didn't conceive of the idea of mobility in the same way, because I do have customers at this point that want their data to not be locked inside of what is VMFS, because you think about how you have to be in VMware's ecosystem, which in a lot of cases is great, right? But even VMware is moving to this more, multi-cloud
the VM
approach.
object wrapper is your boundary. A VMFS volume is your boundary. If you can strip that back,
right?
Because a Windows VM can run in AWS or Azure, but the second you wrap it in a VMX file, it's no longer a portable object.
That solves that other problem that I've been running into with some of the other things we've been doing for like DR up to the cloud. Is I've backed up this VM, and now I've got to convert it to AWS EC2 format.
And that's the thing, and that is a way of solving that. I mean, there's vendors out there that will back something up and convert the entire machine into an AMI and EC2 and spin it up in an EC2 instance. But invariably, it's a game of trying to get up to a point where, okay, we pushed it to AWS, great, it's incremental, and now but there's always a conversion. So there's some, so it starts at 4 hours. We can get it down to a half hour, but the best solution is not having to move the data again at all.
Right.
Which admittedly is can be more, at times more complex, right? Because if you have all of these individual LUNs that you have to, reconnect on the other end. But I think it opens up some real DR, test dev as a service inside of the cloud offerings.
Do you see, I mean, you mentioned Rocky on converged switching, and I know we've spent a lot of time with like fiber channel, and I don't sell fiber channel anymore. I'm sure Yeti, you're the same thing. I don't sell that unless I've got this thing that
usually
I need to bolt it
we
onto.
have an existing fiber channel plant and we need to refresh our switches. It's not, hey, I have this new greenfield project, I want to put fiber channel in for my storage protocol. It's not what I'm hearing a lot.
Right. So there's these converged fiber channel switches we see. There's that kind of stuff. Do you see that? Do you think that we're going to go wholesale onto this? Hey, we're going to use this new protocol. We need the switching to support it, or do you think something's going to come up later that's going to let us do storage over IP as well? So I don't have to have that two different, right? Because right now for us,
well,
it's
it doesn't necessarily need to be
NFS.
too different, does it? The switching, I mean, you can lay in ROSI on a Nexus stack, for example.
Right. Yeah. Nexus actually supports that. The trick is, in order to be able to provide, in fact, some fairly old switches. They've had this around for a while, and it doesn't need to be V2 because that's what allows some in the spec the ability to hop. So the switch needs to support data center bridging technologies. I forget what Causalino you'd know. They used to call it Trill. There you go.
Oh no, trust me. I know this because I went through all these docs, found contradicting information, old information. Cisco.com was challenging to identify exactly what was true and what was not. But yes, all too familiar.
So yeah, I'm struggling with the question there a bit, because it really is an Ethernet switch, right? It's just not running TCP/IP as a protocol on
regardless
top of it.
of convergence, some people like to take that IP data or whatever, right? Even iSCSI traffic or NFS. Some people are more comfortable running that over a separate set of switches rather than converging it, even though you can segment that off with VLANs. It's just a design choice. And I think that's almost a relic of just, hey, I always had a fiber channel network that was separate. I always ran my iSCSI over different switches. I want to do the same thing here.
So let me challenge that one a little bit, because the best iSCSI environments are the ones that are designed like a fiber environment. Because a fiber environment, there was a couple of shortcuts that you could not take. You had to have HBAs, right? And fiber as a protocol is lossless. So the switches are always, by definition, non-blocking.
So that's the thing, right? With a fiber channel environment, you've got that non-blocking, lossless environment, and you don't necessarily get that same thing with iSCSI or NFS. But I'm not doing worldwide node names. I'm not doing all of that fiber channel config that we don't do. That's more of where my question was going. Do you see that being the thing, or is it now I've got to reconfigure this Rocky environment to get storage presented, and it's going to be the same kind of like, well, crap, who's my guy that does fiber channel, or who's my guy that does Rocky? Because now we got to go.
So think of it more this way, because Rocky is just the Ethernet implementation of what really is NVMe over Fabric.
Okay.
And so the question comes up, well, can you run NVMe as a protocol over fiber? And yeah. And I believe that's one we'll put a correction in here, because Rocky is supported today on Pure. NVMe over Fabric is not today, but at some point. So I'll have something more official on there. The entire thing about roadmap stuff on a public forum. But keep in mind that
you've all signed NDAs.
Yeah, exactly. But keep in mind that running NVMe over a fabric is not. It's using either Ethernet or fiber as a backbone to that.
Okay.
In fact, fiber switch vendors would make the case that no, you should absolutely put that on fiber. We've been built from this for forever. Part of that is because they sell fiber switches. And, part of it is because fiber switches are necessarily fast. But yeah, I think that's going to create kind of an pretty interesting world with performance, because we're going to get to a point where it used to be SLC flash inside of, or NAND inside of systems that was used for caching and such, and we're in this world now where Flash is both performant and can also be dense, right, with QLC NAND, and that you can have some of these drives coming out are they're huge. So of course I'm still waiting for the point where Flash actually eclipses the price of spinning disk, and so who knows when. I'm not going to even begin to conjecture on that. But if we think back 5-10 years ago, this is a big difference with where things are, and you even look at the trends in performance. That's changing quite a bit as well. Where a lot of applications, so it's almost like they're diverging, right? We have some application sets that are perfectly happy with S3 storage and batching things, and then you have other applications like OLTP databases and things that really require real-time communications are needing more of that, right? Machine learning,
where nanoseconds matter.
Mm-hmm.
Right.
It's different workloads. I'm writing this app that's optimized for object storage on S3.
Right.
Chris,
so yeah, it's interesting.
I hope this has been fun for you because this has been awesome. I mean, I think we're gonna have to do
absolutely.
this
Spend a minute. Yeah,
more
let's do another one.
regularly. Yeah, I'm down
need
for
some
that.
more live times. This has been a lot of fun.
Yeah, well, we really appreciate you coming on, Chris. Thanks for everybody for joining. And hopefully we'll get to hear those dulcet tones soon. Maybe we can even get a sequel on the intro outro playing too.
There we go.
If you're
do it live.
I got a new bass up there. It's a 5-string fretless, so it's there's been a lot of jazz in my
I feel like we missed an
practicing
opportunity,
time.
Matt. We could have had him do the intro from his studio live.
Shoulda.
Next
time.
Why did I
true.
pipe that in?
I have everything for it right here.
Why did I pipe that in?
You know what we got to do is record
and that
it
bass
and
is fun because
have him lip sync it, right?
There,
you won't
there
actually
you
plug
go.
the bass in, so we can.
Yeah.
Well, then I would have to do my part.
Right.
That intro is actually me and some kind of trying to do, like Chris mentioned, the trailer. Imagine a world where
Mr.
I'm
Movie.
mocking up my own intro.
Mm-hmm.
Yeah. Well, again, thanks, Chris, for joining us. We're looking forward to having you on again, and it's great to have you back.
Thanks, everyone, for coming and watching and listening.
So just so y'all know, we just launched a special opportunity for anybody with upcoming storage needs and would love to talk more about whether Pure might be a good fit for your environment. It's called the Modern Data Pop-Up. So for more details, check us out, ivoxy.com/pop-up, pop-up. I already gave Dustin, our marketing guy, a hard time. So, if you want to beat him up, but it's ivoxy.com/pop-up, pop-up. So yes, it's all SEO. It's above my pay grade. I don't get it either, but yes, hit us up at ivoxy.com/pop-up for more details. And again, if you haven't already subscribed to the podcast, find us on Overcast, Spotify, Apple Podcasts, whatever Google's calling their latest podcast app this week. Find us and give us a 5-star review. We'd very much appreciate it. Any questions, hit us up at podcast@ivoxy.com or find us on the various social media. For Mr. Crow, for Mr. Coslino, I am Matt Yeti. Thanks very much for listening to the very first live edition of Data Center Therapy. Have a good day, everyone.